last video, we have studied Rutherford scattering experiment and its limitation. Rutherford scattering experiments proves that an atom consists of charged particles made up of nucleus around which electrons are rotating. And its limitation is it could not explain with what energy the electrons are circulating in a circular path, because angular momentum study shows if an electron loses its energy, it will fall into the nucleus. So, with what force the electrons are rotating, not explained by Rutherford scattering experiment predictions. Next one is Bohr model of an atom. Bohr model of an atom explains the electrons are circulating in an orbit with associated energy called the stationary levels or energy levels. Next we are going to see the next level of the atomic model, the wave and particle, dual nature of electron, duality of matter. So otherwise in mathematically it is derived by equation called Debroglie equation, and also the dual nature of electron explained by Heisenberg uncertainty principle. So now we are going to see the Debroglie equation which explains, which combines particle and wave nature of electron. Debroglie equation, duality of electron, particle and wave nature of electron derived by the Debroglie equation. According to Debroglie equation, or on what basis Debroglie equation is derived, is the wave nature of electron is explained by J.J. Thomson and Davison-Germer experimental prediction shows the electron possesses wave nature like that of X-ray because the pattern obtained from their experiment shows the electron movement is similar to that of X-rays. So, supports wave nature of electron. And also there are certain experiments which shows or support particle nature of electron. What are the phenomenon which supports the particle nature of electron is phosphorescence, the glowing of certain substance in a particular spot. That is called phosphorescence, you studied in lower classes. And also Mulligan oil drop experiment in physics, the E/m ratio supports particle nature of electron. And also the photoelectric effect, the release of quantum of energy exhibits both the particle and wave nature. So these are all the experimental evidences which supports the wave nature of electron, and these are all the experimental evidences which supports particle nature of electron. So the scientist called Debroglie derived equation which combines particle and wave nature of electron. Experiments which shows particle and wave nature of electrons, the dual nature of electron, particle nature and wave nature. Debroglie equation, the dual nature of matter electron. According to Planck's quantum hypothesis which supports the wave nature, the energy released is given as h mu, Planck's constant, and frequency of wave. And Einstein mass energy relationship is E is equal to mc squared, mass and velocity of a particle. Now we are combining the wave nature and particle nature of electron in the form of mathematical equation. That is, we are equating h mu is equal to mc squared, wave nature and particle nature. Here mu frequency is given by c by lambda, wavelength and the speed of a particle. So by substituting the value of mu in this equation, h mu is equal to, here instead of mu we are substituting c by lambda, thereby we can write h c by lambda is equal to mc squared. On simplifying, lambda is equal to h c mc squared. On simplifying, we can get lambda is equal to h by mc, mass into velocity. The velocity, mass into velocity actually gives the value of momentum, the p. So instead of writing c, we can write v also, and instead of writing the mv, mass into velocity actually is a momentum, we can also write the p, momentum. So according to the Debroglie, the dual nature of electron is explained in the form of mathematical equation called Debroglie equation, that is lambda is equal to h by mc or lambda is equal to h by p. H is Planck's constant, p is momentum, that is h is Planck's constant, Here the mass and velocity, the lambda is wavelength, called de Broglie equation.